Bearings, the critical elements of overall bridge system. It's a small part of overall structure cost, but if they function improperly can potentially cause a failure of the bridge structure. A bridge is mainly consists of two major parts, superstructure and substructure. The portion of a bridge structure from bearings to the above called as superstructure, and below bearings it is called as substructure. Structures were previously only considered to be rigid and immovable bodies until the end of 18th century. But with the passage of time, engineers realized that there is some dimensional changes and deformation in the structure due to various factors, which are thermal expansion and contraction. We know materials expand when they are heated. In hot weather, bridges having a long span expands and push the supports, and materials contract when they are cooled. So in a cold weather, bridges having a long span contracts and pull the supports. Longitudinal forces, braking and tractive. Suppose a vehicle crossing the bridge from that direction and suddenly apply the brakes above the bridge. Braking force resulting from this application of brakes. And if the vehicle suddenly accelerates just above the bridge. Tractive effect caused through the acceleration of the driving wheels. Centrifugal forces, which is the apparent force act outward direction on any object in a rotating frame. When a bridge is situated on a curve and a vehicle will cross it with a velocity, centrifugal force will act. All portions of the structure will be affected by the centrifugal action by the moving vehicle. By this effect, Ultadanga flyover at Kolkata collapsed on March 2013, while the heavy goods truck crossed the flyover under the curved stretches. The bearings under the 40-meter steel girder at the curve couldn't able to resist the centrifugal action and crashed into the canal 7 meters below. Due to elastic deformation of bridge under live load, due to the seismic forces during earthquake, due to wind loads, water current forces, etc. These factors continuously push and pull the supports until it achieves the freedom required, and in this process causing damages to the structures. Since the bearings are introduced between the superstructure and substructure for accommodation of various movements and transfer the load from superstructure to substructure by absorbing the shock of vibration. And this is pedestal, which provides the clearance between superstructure to substructure so that it can move freely. Bearings are classified according to the material used and freedom of movement of the rigid body, which is termed as degree of freedom. There are total 6 degrees of freedom in a 3D space. Translation in the x-axis along the roadway, rotation in the x-axis, translation in the y-axis across the roadway, rotation in the y-axis, translation in the z-axis vertically, and rotation along the z-axis. Sliding bearings. It is a simple arrangement of two plates sliding over the other. These bearings permits translational movements in longitudinal direction as well as in the transverse direction, but no rotational movements permitted. When a mild steel over a mild steel plate used in sliding bearing, the coefficient of friction will be in between 0.2 to 0.3. The coefficient of friction will be 0.15 when the mild steel over the phosphor bronze plate used, and the coefficient of friction will be less than 0.08 when the PTFE used over the stainless steel plate. PTFE means polytetrafluoroethylene, widely known as Teflon, which is also used as non-stick coating for frying pan and other cookware. It has one of the lowest coefficient of friction of any solid. Pin bearings are one of the oldest type of bearings, permits rotational movement and prevent translational movement. The pin transfers the forces by rotation from the sole plate, which is attached to the superstructure, to the masonry plate, which is attached to the substructure. These plates are usually anchored by bolting to the substructure, which resists the translational movement. Rocker bearings can support high loads, allow translation movement in longitudinal direction by simply rocking back and forth, and rotational movement in longitudinal direction by the rotation of pin attached in it. The pintail is a vertical pin which is driven into the masonry plate at the top that prevents the rocker from sliding instead of rocking. And this is the maximum eccentricity of the rocker bearing. Rocker bearings can be either fabricated without pin, which is linear rocker bearing, or with pin, which is called as pinned rocker bearing. Roller bearings, which are generally consist of cylindrical heavy metal rollers which bear the load and roll on the masonry plate. Only longitudinal transverse movement permitted on roller bearings by rolling. These are stopper plates, prevents over-rolling of the rollers. And this is guide, which prevent the movements in transverse direction. This tie bar maintains the fixed spacing. between the roller during movement. There are different types of roller bearings are available. Single roller bearings, multiple roller bearings, gear roller bearings, and rocker cum roller bearings. Merits of steel bearings. Steel bearings are economical, relatively cheap, easily fabricated by manufacturer, and easy to install. There are some demerits of steel bearings: tilting under high load, high maintenance cost, some parts always requires lubrication and worn out in improper lubrication. Rust and corrosion in steel bearings can cause freezing of the bearings. Elastomeric bearings allows movement in all directions by elastic deformation and twisting. Elastomeric pad is made of elastomer, which is natural rubber or synthetic rubber. When in a heavy load, the deformation of elastomeric pad exceeds its allowable limit, it can cause of sliding. And to prevent this type of bulging, the horizontal steel plates are provided. The thickness and number of plates depends on the magnitude of vertical loads. Elastomeric bearings can be rectangular or circular in shape depending on the design calculations. Pot bearings are the combination of sliding bearing and elastomeric bearing. It allows three-dimensional movement in all directions. This is the top plate attached with superstructure by bolting. This is guide provided for the guidance during sliding of the plate. And this is the sliding plan, which slides over the polytetrafluoroethylene sheet. This is the bottom plate anchored with the substructure. Here is the pot attached with the bottom plate. And this is a circular elastomeric bearing pad which is inserted into the pot. This is the internal seal which seals the elastomeric pad and protects the edges of it. This is the cover of pot which is a piston. When the piston transfers the high pressure into the elastomeric bearing, it behaves like a viscous fluid and moves in all directions freely. If you like this video, make sure you hit the subscribe button below and click on the bell to turn on the notification.